Topic 1, Day 7, Exponential and Logarithmic Functions. So I want to do a quick overview of what the exponential and logarithmic parent functions look like. So we'll see the first one is our exponential parent function, y equals 2 to the power of x. And what you'll find is we have no x-intercepts, right? Our x-axis is right here, and our function gets infinitely close to that x-axis, but it never crosses. All right, so there's no x-intercepts. Our y-intercept is at 0, 1. The domain is all real numbers, but the range has to be values that are greater than 0. And we have an asymptote at y equals 0. We'll never cross. Our logarithmic parent function, we have an x-intercept at 1, 0, but no y-intercept because, again, we have that vertical asymptote going straight up and down. All right, so that function will get infinitely close to that value, but it will never cross our y-axis. The domain is any values of x that are greater than 0, and the range is all real numbers, and then again, the asymptote at x equals 0. When we're asked to solve logarithmic functions, we essentially have two strategies. All right, strategy number 1 is if you could somehow get it where you have all of your logs on one side completely condensed and then a constant on the other side, you can convert it into exponential form. Your second strategy is if you have log of x equal to log of y, you can set x equal to y and then solve. All right, you'll often have to use your logarithm rules to manipulate before you get it into one of these two strategies. So you're going to have to kind of do some guessing and checking and some just practice until you start to develop an intuition. Let's try our first teacher example. It says to solve log base 6 of x plus log base 6 of x minus 5 equal to 2. When I look at this, I see all my logs on one side, and then I see a constant 2. So I'm already thinking, okay, if I have that constant on one side, if I can combine the logs on the other side, I can convert into exponential form. So that's kind of the strategy I'm going to go into this with. Since these are being added together, I want to use my product rule to condense them. So I'm going to rewrite log base 6 x times x minus 5 equals 2, right? Now that I just have my log, I can do two things. Number 1, I can distribute my x to the x minus 5, and or I can convert it into exponential form, right? Either of those steps is fine, okay? So I'm going to distribute first, and then I'm going to convert it, but you could do it the other way around. So here I'm going to take 6 squared equals x minus 5. 6 squared is 36. And then I'm going to distribute x squared minus 5x, right? Now, this is something we know how to solve. It's just a quadratic. We need to get it set equal to 0. So I'm going to subtract 36 on both sides. 0 equals x squared minus 5x minus 36. From here, we can think, how do I solve a quadratic? I can factor, I can graph, I can use a quadratic formula. I'm going to factor because I know these numbers will factor. But if you weren't sure or you didn't feel very confident that they would be factorable, quadratic formula is good. If you have access to the calculator, you could just graph it. So A, B, C, A is 1, B is negative 5, C is negative 36. Let's see, I have A, C is going to be negative 36. My B value is negative 5. And I'm going to think, what numbers multiply to give you negative 36, add to give me negative 5? You get negative 9 and 4. So negative 9 times 4 equals 36. Negative 9 plus 4 equals negative 5. Since I just have that x squared, x minus 9, x plus 4 equals 0. So I set them individually, equal to 0, and then get x equals 9 and x equals -4. Okay, great. There's one thing that we have to keep in mind. When we looked at our logarithmic functions here, our domain was only when our x values are greater than 0, right? X cannot be negative values, x cannot be 0. So right here, when we get x is equal to -4, it's actually not in our domain. So if we were to plug in a -4, like log base 6 of -4, it wouldn't work. So our only solution here is x equals 9, because -4 is not in the domain. Okay, try student example number 1 on your own. Teacher example number 2 asks us to solve log base 5 of x minus log base 5 of 4 equals 2 plus log base 5 of 3. So now I have log on one side and then a constant and a log on the other side. I'm going to subtract the log here again so that I can try to get it logs on one side completely condensed and then my constant number without a log on the other side. So if I do that, I get log base 5 of x minus log base 5 of 4 minus log base 5 of 3 equals 2. And now I can use the quotient rule, and I get log base 5 of x, and then divided by, and then I have 4, and I have a 3. And all of that's going to be equal to 2. I'm going to reduce log base 5 x over 12 equals 2. Now that I have log on one side, constant on the other, I can convert it into exponential form. 5 squared equals x over 12. And then multiply by 12 on both sides. I get x equals 300. 300 is a positive number. It is not 0, it's not negative. So it should work when we plug that in. That's our final answer. And you can go ahead and try student example number 2 on your own.